also the CEO of Consumer.io. That's the startup that Cartwheel Web puts time into. I graduated from the Massachusetts Institute of Technology in 2005, EECS, and I'm Filipino American. My mom grew up in the Philippines, and I'm also here visiting my aunt and my grandma who live in Parañaque. My grandma just turned 98 years old. I'm here today because I love Python. As Danny mentioned, passion is very, very important to your Python career, and I just, I wouldn't be here today if I didn't care. And I am a core developer of the Open Comparison open source project. It's a Python and Django-based package comparison framework, and I'm a contributor to a number of other open source projects. I co-founded PyLadies, which is a women's Python networking and mentorship group, and I also helped organize PyConPh, and I'm a member of the Python Software Foundation. And I also met my fiance, Daniel Greenfeld, at PyCon 2010. And here's a photo of us tangoing. So, a quick overview. I'm going to start out with code readability. This is why we all use Python. We love the white space, and I'm going to go into beyond that, what makes code readable. I'm going to show you some great tools, linters and code checkers that you can use to help make your code more readable. And I'm going to show you where you can find free reusable Python libraries for your applications. And then finally, I'm going to show you how you can take your own reusable modules and package them up for reuse so that other people can benefit from them, so that you can go on the Python package index and see how many downloads you have. It's a lot of fun. So code readability. If you want to be a great Python developer, it's not about being clever and being able to do really complicated things in one line of code. It's being a great Python developer is about writing code that is very clear and understandable. It's so clear that anyone who picks it up can understand it when they look at it without having to study it in detail. The best Python code is compact, but it's not too compact. So if you compare a Java program with a Python program, the Python program will be more compact because that's just the nature of Python. You don't have all these extra braces everywhere, but but the best Python code is not super compact, like one line clever bits of code everywhere. So when you write code, it should be self-documenting, but you shouldn't just rely on it to be self-documenting. You should also document it yourself. So here's an example of a simple function that tests whether a variable x is even. And here we've got if x mod 2 is 0, return true, otherwise return false. Can it be made cleaner? One thing you can do with Python, you don't need that else in your function, because if you return true in line 3 over there, then you're not even going to get to line 4. So this is something you can do for a bit of just readability. Something else you can do is compact it further. You don't need the return true, return false. You can just return the result of evaluating the expression x modulus 2 equals 0. And that's better, but there's something missing here. what's missing is the doc string. There's this this bit of English in three enclosed in triple quotes. That's the way that you document a Python function. There is this thing called the Zen of Python, which is the philosophy of Python coding, how you should think about all of your Python programs. And if you go into your Python shell, you can type import this. So whoever's got a shell, try typing that if you've never done it before. And what happens is you see the Zen of Python. It's this this really nice poem that summarizes the philosophy of Python. So there's beautiful is better than ugly. A good one, flat is better than nested. Like if you have a simple if statement with just one layer, it's much simpler than if you have, say, 5 layers of nested if statements. When you have more nesting, it's not as readable. So a big part of being a Python developer is learning to be elegant in your coding. And it goes on. There is PEP 8. This is the Python style guide. It specifies that you should use 4 spaces for your indentation. Don't use tabs. If you mix tabs and spaces, your programs won't run. People will have problems using your code. Always stick to 4 spaces. It also specifies to use other things like blank lines between your function definitions or class definitions. And there's so much more. I highly recommend going online and looking for PEP 8. Now I'm going to go into the tools for code readability. So think of these kind of like spell check programs which automatically check your code for readability and for problems and alert you when there's any problems. The first one, the editor I like to use is Sublime Text 2. It's a text editor that is programmable in Python. Actually, you can write plugins in Python, and you can also go into package control and download Python plugins and install them. My favorite plugin is this one called Sublime Linter, which goes through your code and it highlights the lines of code that are not PEP 8 compliant. In other words, that do not meet the style guide. So, for example, here it's highlighting lines 14 and 19. It's highlighting them actually because there needs to be a line between a line after the function definition. It doesn't catch everything, so it doesn't catch the capitalization of the functions, but it does a pretty good job with helping you have cleaner, more organized code. And I mentioned they're simple Python files, so if you want to write a similar plugin, all you do is put a Python file in the packages directory of Sublime. Next tool is called pep8.py. This is a command line checker for PEP 8 style. So the way it works, you run this command called pep8 at the command line, and followed by the name of your Python file as an argument. And what you get out is this really nice output showing which lines are not PEP 8 compliant, which lines you can go in and fix. And it also shows, see the E302, the W391, those are referring to sections of the actual PEP 8 specification, which you can go online and read. The final tool is kind of like pep8.py, but it's much more advanced. It's a source code analyzer called Pylint. what you do, you run pilot followed by the name of your Python file, and then you get some output. And it, as you can see, it's much more voluminous. It goes on, and there's much more pages. I'm just cutting it off here. But that, both Pilot and PEP8 are available from the Python package index. And these slides will be available online later. I'll post it on Twitter so you can get all the URLs. So now, finding Python libraries, in other words, free stuff. As a Python developer, you get tons of free stuff. These are packages that people have written. These are both packages that come installed with Python and ones that you can install separately. So where do you get these free reusable Python libraries? The first place is the Python standard library, and that is already included with Python. So whether you're talking about your own system Python that comes installed by default, or whether you downloaded Python from python.org and installed it, you already have access to the Python standard library. And it's kind of like the C standard library, or other languages have standard libraries where there's all the basic essentials that the core Python developers can think of including. They added and are kind of outdated, but there's great stuff in there. The second is the Python package index, which Paula mentioned earlier. There's currently over 21,000 packages. As of last year when I checked, there were 16,000 packages. So it's growing and it's growing, and not only that, it is going to continue to grow if you submit packages, which I encourage you to do, even if you just write some little simple utility for your own purposes. You never know who's going to need it. And why should you reuse code? There's this tendency among a lot of people who are new to development that why will I reuse someone else's library? I'm smart, I can write it myself. But the thing is that as you gain more experience, you realize Python helps you avoid reinventing the wheel, and the more you don't reinvent the wheel, that's more time that you spend writing innovative Python programs, or just writing things that have never been written before. So I encourage you all to avoid not invented here syndrome and reuse what you can whenever you can. So yeah, I mentioned the Python standard library. As I said, you don't have to install it. All you do is import the modules, as Paula mentioned earlier, and then just start using the modules right away. So for example, there's the math module. So I do an import math, and then from here I can call different methods. So here I'm calling the ceiling method. So the output of ceiling is to take the number and raise it up to whatever the next whole integer is. So 2.03 gets raised to 3. Floor is the opposite. So floor will drop it down to 2 if it's anything between 2 and 3, but not 3. It's got things like log, and it even has more complex methods. So there's the error function, which you might know from statistics. The math library is implemented as thin wrappers around the C standard library's math library. So if you're familiar with that, it's going to be super simple for you to transition over and use the equivalent in Python. Another one is random. So here, random.random returns a random float between 0 and 1. If you want to use the uniform distribution between 0 and 100, you can do this. You can combine the modules. So like here I'm combining floor with uniform, and I'm getting a nicer value between 0 and 100. Or I could just use rand range, which you may have seen, and just that's just like a shortcut. So besides the standard library, I mentioned the Python package index. It's pypi.python.org, and every single one of those packages has been created by members of the Python community. So you saw some great examples that in the first part of sample packages that you can get from PyPI. It's more conservative. It changes very little over time. There's few additions, few deprecations, few changes. It is, which means that it's very stable. If you absolutely must have stability, you should, standard library is a great place to use packages from. On PyPI, things change much more rapidly. It's more up to the developers who maintain the packages. That doesn't mean that it's unstable though. It's because sometimes the PyPI packages are actually better than the equivalent standard library ones. And a good example of this is the requests library by Kenneth Reitz. It is a improved version of the URL lib2 module, which is included with the standard library. So you can do gets, posts, just really easily with requests. Whereas with URL lib2, your code will be a lot more complex, and that's not a good thing. And if you're in doubt about whether to use one library or another, that's where you just go online and you ask around. That's where the Philippine Python user group is a fantastic place to ask. Just go on the Facebook group and ask, should I use this package, and get some feedback, because Python coding is not just about coding on your own, it's also about talking to other people in the community. So installing packages the wrong way and the right way. The wrong way is to install your Python library system-wide. You can easily make a mess of your system, and it's fine to install things system-wide if you're just starting out, you're just playing around. But once you get into actual work projects or school projects where you have say one project that depends on a certain set of packages and another project which depends on a completely different set, you might have conflicts if you're installing everything system-wide. So the right way to do things is to use these two tools, pip and virtualenv. Pip is a good package installer, and it works very well with virtualenv. Virtualenv gives you the ability to create isolated environments for your different Python projects. And I strongly recommend using this third tool called virtualenv wrapper with those previous tools to have the name of the virtualenv in parentheses. And now here I'm CDing into my consumer IO project directory, and now I can work on it. I can do run server because this one is a Django project. I can do whatever I want in here, and so keep working. When I'm finished working on this project, let's say I want to switch to just experimenting with other things, that's when I deactivate this virtual environment. And so now you'll see the start of the shell prompt changes. And now if I want to work on my experiments, I I type work on experiments to activate that virtual environment, and now you'll see the shell prompt change again, and now I can run any other Python code from my experiments directory using the packages that are dependencies of my own experiments. And as I mentioned, you use pip to install packages into virtuals. So you can do pip install the package name equals the version number of the package that you want. And you may have heard of a tool called Easy Install. Pip is kind of like that. Pip is kind of like the next generation of Easy Install. It's much better than Easy Install. It won't install things system-wide. It'll install them into your virtual environments. And if you want to use it on Windows, you will have to use Cygwin, I believe. You may be able to hack it to use it without Cygwin. It's easier to install on Linux and Mac. And just install packages from a file that is saved as requirements.txt. And so, for example, in this file, I have Flask. I have a library I like for CSS sprites called Glue. I have Pillow, which is the nice version of Pill, and I have Django 1.4. And usually when you're working on a Python project, you don't just have one dependency. You usually don't even have just 4 dependencies. You could have hundreds of dependencies. So it gets unmanageable if you have a lot of dependencies. And you can just, if you're just playing around, if you're just testing out a code snippet, you can just create a virtual and install the package name equals the version number of it, as I mentioned. But do that for experimentation only. Otherwise, use a requirements.txt file. And once you've installed your packages, you can then just import your Python code from modules or submodules, and you do this as you would work with the standard library. It works exactly the same way. And the nice thing is you don't have to deal with downloading files manually and double clicking on them. It's much cleaner. So now, writing reusable code, that is a part of your, that is going to become central to your Python development career. The more code you write, the more you're going to not just reuse other libraries, but write your own reusable libraries. So you've heard about modules a lot. Just to reiterate, a module is just a simple file that contains Python definitions and statements. So for example, this is a file called divisible.py, and it just has this one function, is even, that's defined in it. And if I import this, I can do from divisible import is even to import this function into any other code I want. Means that it's a package. That's just a convention that you'll have to do. And then within this directory, I can also add subdirectories. So for example, formats, I would just put an init.py in there, and then I can just put other files for my submodules, and same thing with effects. So this is just an example of a simple Python sound processing package. Now, if I wanted to import from this, I could just use dot notation to import whatever functions I wanted. So here I'm doing from sound.formats.wave, the wave module in their wave.py. I'm importing a function called readWave. Let's say I want to read a wave file. And if you're writing a package, you will at some point you'll realize that you you have one module in the package that requires another module in the package, and that's where these intra-package imports come in. So you can do relative imports between submodules of package, where you use this dot notation, which is similar to the dots of the command line. So from the current directory import echo, or from the parent directory import formats, or if you want to go parent then filters import equalizer. You can also do absolute imports when you're importing from one submodule to another. So all you do is import from the package root. So explicitly start your import with the package root, and you'll be fine. And now these rules are for imports within a package. If you want to import from outside of a package, those rules don't apply. That's where you have to actually start using the package as a reusable library, as I mentioned earlier. So if you have to, you can add it to PyConPh using sys.path.append or editing your environment variable. That's okay, but what's better is to use the tricks that I mentioned in the previous section with pip and virtualenv, where you just install it into your virtual environment, and then you're all set. And that if you haven't done this, that you try it out with a sample snippet of code just to get a feel for it, and it's really great. Can I ask, actually, raise your hand if you have any packages on the Python package index? A few of you. Okay, that's awesome. So I encourage everyone to try this. And thank you very much. So come find me throughout the conference if you have questions. Please introduce yourself. I would love to meet all of you. And you can find me on Twitter and ping me later if you want on Twitter or by email. So that's it. Any questions? First or wave. And if you really wanted to, you could do import star, but that's considered bad practice. It's better to import specific things rather than importing everything, because it could get messy. That's a good question. Has an option called --no site packages. So I'm not sure if the latest one has already switched. Okay, so you can use virtualenv in a way that it copies the site packages directory from your machine over to the virtualenv, or you can use it in such a way that it creates an empty virtual environment for you to install things into. And if you look up the documentation, it can tell you which of those is the default.
I've been trying to use PIP recently, but I can't seem to find a way to update my packages. Is that possible?
To update all the packages.
Or maybe just the ones.
Okay. So there is an upgrade command to pip. If you do, I'd have to look at the documentation, but I think it's -U, which so if you do like pip install -U, the name of the package and the version that you want it to update to, it'll update to that specific version.